Hello, this is Dr. Y.S. Rao. We have explained about how to design a IoT board. It's not only IoT board, it's mainly designed for do-it-yourself, self-learning, and implementation of various case studies. So the circuit diagram is explained in the first session. What are the various components are there on the board? Which components are placed where? In the second session, we have explained about the circuit diagram, that is placement of the components, layout design, and identification of the component, placement of the component, soldering of the components, testing of the board. With that assumption, you have gone through those two videos and also you have fabricated the board, tested the board. Now let us see how to program the hardware. We strongly recommend before you program this IoT kit, which is having various peripherals, sensors, communication devices, one should do first the one should understand the compiler syntax, and what way it is different from conventional C program, what are those keywords, structure of the program, and so on. Second reason why you should practice embedded C, the reason is computer is having virtual environment. You have a physical memory, you have a secondary memory, hard disk is there, cache is there, multi-core CPU is there. So due to that, whatever you do, most of the programs are all being managed by the operating system. So you are not really aware of the physical resources, constraints while writing the program. Even you don't understand what do you mean by real timeness because operating system is not allowing you to do the things. But this doesn't work in industrial coding, IoT applications. Whatever you write the code on your computer, finally, whatever may be the data types you use, they may be there, they may not be there, might not be there on the CPU, but it will emulate, it will convert into its equivalent code. Let's say, for example, you have defined a floating point number. 95% of the CPUs doesn't have floating point unit. That means floating point number support is not there in any of these CPUs, including most of the ARM processors. However, compiler is allowing you to define the data types. But in the backend, what it will do? It will convert into its equivalent integer forms. It will round the numbers. It will truncate the numbers. So there is a possibility that there is an error in the data. That may lead to failure of your entire system because you are not aware of it. You have only simulated on the computer, but end of the day you want to make a product, and once you make a product, your programs doesn't work. A, data type support is not there. B, hardware doesn't have virtuality, hard disk, memory management, operating system support. Those things are not there. See, your product need to be real time. Real time means in time. There is no question of missing any event or delays. The event should be taken care in time, not before, not after. If you miss any sample, it may lead to catastrophic. Anything accident can happen. A, in a healthcare sector, there may be a seriousness in about the patient condition. Anything can happen if you miss even a sample, or short circuit may happen in electrical and electronic systems. Anything can happen. So, however, in computer, you are not taking care of those issues. But here we should take care. That's the reason why I always advise you. There is no hurry in developing the applications. First, extensively, at least 1 week, 15 days, practice the compiler, data types, understand their behavior. So, those sessions I have recorded earlier. So, I suggest you go through these videos about Arduino compiler, Arduino data types, and the syntax of the compiler itself, like operators, conditional statements, and so on. So, but do not simulate this. All these programs do not use any computer-based simulation softwares. Again, you are making a blunder. You Because simulations are not 100% foolproof. They only verify functionality of the programs, not the real-time constraints. So this entire code you verify it on the hardware. So let us start from this point that I am assuming at least the data types syntax you have verified on the hardware. From here onwards, I am focusing on explaining the programs related to this board. In the sense, whatever so far I explained the circuit diagram layout, components which I have placed, only those programs I am explaining. Maybe some other video I will focus only on the case studies like IoT protocols or dashboard design on cloud or mobile phone and so on. All right, let's after seeing the videos, let's practice it. Though I explained in those videos, let me repeat. I am sharing this folder, or you can download it from the internet also. First, install the Arduino compiler. Just you have to keep on clicking the next button. The compiler will be installed without any configuration. Once the installation is done, then the second step is you have to configure your board, hardware configuration and software configuration. So how do you do that? When you connect the board, this board, make sure this switch is off. You don't need to connect any external battery right now, unless when you go for robotic applications or relay based applications. Even you don't need to put the jumper here. So only USB cable, connect the USB cable here. The other end of the USB cable, connect to the computer USB. When you connect it, type device manager on your PC. The device manager, look for ports. What is written as a ports in bracket COM and LPT. COM means serial communication, LPT means parallel communication. This will appear. when you connect it, or maybe in other devices. Sometimes first time where you're installing, it may happen that in other devices that CP210 or serial to USB to serial converter, that name may appear. Since I have already installed the CP210 Silicon Labs, this bridge is nothing but you have one bridge here which will convert USB to UART conversion. The reason is computer doesn't have serial port and microcontroller doesn't have USB. So we are using a bridge which will convert serial to USB form. That is called protocol converter. So you need to install the software also for that. So how to install the software? Once you connect it, if this is not showing Silicon Lab CP210 in the bracket COM number, the number may be different. Right click on that where some exclamation, some yellow color highlight is there, update driver. Then you say browse my computer, and in browse you should select the same folder which I have shown right now, this folder. You extract this folder CP210, select this CP210 universal window driver. This you should select it from the device manager, from the browse window CP210. All right, so once you select it, say for example, I will show you, see this one. You select this CP210 universal Windows driver and you say OK and say next. Then the installation will be done and it will say that Windows has successfully updated the driver, and you will notice that the number will appear. If you want to confirm, disconnect the USB, then you will notice that IO ports will disappear. Again, if you connect it, right, the USB to UART converter with port number will appear. This is the after installation of the Arduino compiler, install the driver. These are the two things that is called configuration, hardware configuration. Now let us see the software configuration, means compiler configuration. So once you install the compiler, on your screen you will have the Arduino compiler icon. All right, go to file. For you, since when you do it first time, and in my earlier data types videos, void setup, void loop. That is how the structure of the Arduino compiler. What void setup means, whatever you write in void setup is executed only once, and whatever you write in void loop will be executed again and again. So generally we initialization programs we write here, like defining the data types, variables, hardware initialization, and your main code which you want to execute again and again, or even if you want to execute only once, terminate at the end with the while loop. So put that remaining executable code, your application code, in the void loop. Okay, so what is hardware, what is how to configure the compiler? Go to file, in preferences. Here initially this is blank in your case. You copy this, whatever I have provided, link, right? This link you copy, and in your preferences, right here, you paste this URL. The reason is we are providing a path to look for the repositories. Say OK. Then go to tools. Make sure you have internet connectivity on your computer. Sometimes your firewall of your institute may block this installation. So either you have to bypass the firewall or provide the internet through your mobile phone. Go to tools, go to board and board manager. Type here, right, in this window ESP32. Right here you have to type ESP32. Okay, type ESP32. When you type ESP32, in my case it is saying installed, but in your case it will ask you, do you want to install? Say yes. You install that. That is the first step. You should do that. If you are using some other controller, like say Node MCU, then type ESP8266. So even this is also installed in my computer, but in your case, you say install. So these are the two major CPUs right now you can think of it. But in future, whichever is the Arduino compiler supports those CPUs. Once the installation is done, you can verify in your tools, board, you will notice the ESP32, ESP8266, whichever you have installed, the list of those controllers should appear. For this Edu-Robo, we are supposed to select a device called Do It ESP32 Development Kit V1. This is our CPU. The moment you select it, then that CPU name will appear here on the bottom of your screen, and also the port, tools, port. Right now it is showing COM3 because in device manager also it is COM3. You should select the same port, right? So these are the two things, hardware configuration and software configuration, right? Before we actually write the various hardware related programs, peripheral related programs, sensor related programs, wireless communication related programs, I recommended to first write all those data types programs, various conditional statements, operators, arrays, pointers, complete syntax like a full C program. You should practice here. Most importantly, I also asked for write a mathematical models, some differential equations, right? Or some soft computing techniques. Simple Ohm's law, implement here and see the results. So that's my assumption. Okay. Now to verify your board, right, this hardware is working or not, two simple programs without writing, which are already there, let us test them. Like I said, switch off this one, this switch, and no jumper should be, no external battery supply.